Hi, my name is Shayna Bayo, and I will be talking about data structures. I first will be talking about the differences between an array list, and linked list. An array is basically a simple array that has a fixed size. You can store primitives and objects in an array. I have an example code called showArray that has this example. You can only do a fixed size like this one where it has only 3 elements that can be put in it, and you can only access it through the element numbers, the index numbers, using these brackets. And if you run this, you can see that it can only have 3 elements in it because that's what the fixed size was. And you can loop through it also to traverse the array. And that's an array. It's useful because it takes up less memory, and you're only accessing it like directly, and it's great if you already know the size. The difference is for an array list, like this example. Here I have a method called showArrayList. An array list also uses an array, built from an array, but it's dynamic. It can grow and shrink whenever you need it. It's good for if you don't really know exactly the size of your data, or you're trying to change the amount of data, or you want to add data or something. The difference is that it can only be used for one type of data type, and holds objects. And here, this is how you initialize an array list, which is a little bit different. You're not using brackets. When you run this method, I'm showing an example of how you would add the number 1, and then you add 2, and you add 3, and see how you can see that it's changing the size of the array every time you add it. And you can also loop through the array list also, similarly to the array. And you can also use specific methods to remove parts of the array, which is why it also takes up more memory because of that. But it is more dynamic and useful that way. And now I will show a linked list, which is similar to an array list. But the difference between a linked list, here's my method for a linked list. The difference between that one, well, it's similar because you initialize it similarly to an array list. And you still use the same types of methods like add and remove. The difference, though, is that a linked list basically contains items linked together, and to add a new item, it has to be basically put into like a new container and linked to an existing container. A linked list is basically really useful. It's better than an array list when it comes to things like inserting or removing items, which is why you would sometimes use a linked list instead. It's better for collection for a large amount of data and really manipulating that data. Oh yeah, I forgot that arrays are great for multi-dimensional arrays too. And let me just run this linked list method, and it's kind of similar to an array list. Okay, and now I will be showing the difference between stacks and queues. I have 2 methods called showStack and showQueue. The differences are that stacks are a last in, first out system, and a queue is a first in, first out system. So with a stack, it's kind of like they're stacking them on top of each other. The top is the last in and would be the first to be removed from the stack. And you would use methods like push to add elements and pop to remove elements. You have to have one pointer pointing to the top. If you run this, I have both of them showing at the same time. See how when you added 1, and then you add 2, and then you add 3, it's stacking. And so, and then if you remove them, you would use the method pop, and it would take off the top one, which is the number 3. So that's that example for stacks. And for a queue, it's like standing in a line, This is useful when you're adding a lot to your data collection compared to removing from the collection. There's difference is that you have two pointers pointed to the front and back of the queue. You add at the back and remove from the front. And to remove, you would use the methods called dequeue, and to add, you would enqueue. So let me run. Well, I already ran it. So it looks the same, but the difference is that when you're removing, like from here, you are removing from the front. See how it removed number 1 from here. One of the useful things that I found out about stacks is that it's useful for solving recursion problems, and it's used in Java virtual machines and to evaluate and convert expressions and a ton of other usages. And queues are better for solving sequential processing problems. It's also good to use as a wait list and for scheduling. And now I'll be talking about hash tables and the difference between arrays and hash tables and when to use them. This is my method called show hash table. You still declare a hash table sort of similar to the way you would declare a queue or a stack, but it's a little bit different because a hash table would always have a key and a value. So it could be different, not the same type all the time. Like in this example, it's a string and an integer type. And they use the hash map class, which is a little bit different. So it always has a key and a value. So for this example, my keys are the strings A, B, C, and the values are 1, 2, 3, and they're always going to be a paired order. It's kind of like an array, but not really, because each element is associated with a key instead of being associated with indexes. They use similar like get methods like an array. And let's see, what else do they do? Also, one of the differences is also that hash tables don't have a size limit, and there's no order, unlike arrays. Like basically, if you insert elements into a hash table, it's not going to change the order or any of the values, unlike when you do an array. Hash tables also take up more memory to store everything because of the keys and the values. And that is, I forgot. And then I should run this and see how basically they're paired up. A equals 1, B equals 2, C equals 3. And this is useful for searching for things. And now I'm going to talk about my binary tree. For the data structure challenge, I had already created the name node custom tree class, which was right here that I completed. Kind of long. Basically, a binary tree is useful for searching and sorting data. When you create a binary search tree, it's made up of nodes, parent nodes, and children nodes. I created a little example code using that custom node class that I created. For this, you have to first declare the initialize the tree and start out with a root, which I made the number 4, or a string number 4. It has to have a root, and then they have child subtrees. For this example, I inserted the subtree, the child tree 2 and 1, 3, 5, 6. For my particular class, when I wrote out the insert method, we use also a recursion method in there. Basically for this, with the binary sort tree, you always add the left subtree is always less than the root, than the parent node, and the right subtree is always greater, has a greater value. So I kind of have an example picture showing how it worked. 4 is the root, and then when you insert 2, because it was initially empty, it would go to the left. And then when you insert 1, because it's no longer empty, it's still less than 4, but it's no longer empty, so now you basically do a recursion method and do that insert method again, and then you would go to the left of number 2. And then for 3, you go to the right because it's more than number 2, etc. And now I just ran the method right here, and this is how you would show the binary tree. It would be traversed in order because I created it that way in the toString method. And that is my data structure example. Thank you and have a good day.